Good day everyone and welcome.
Today we delve into the fascinating world of large language models with our focus on RAFT, Adapting Language Model to Domain-Specific RAG. This groundbreaking research tackles the challenge of adapting these models to specialized domains, aiming to maximize accuracy based on specific document sets. It introduces RAFT, a novel strategy that combines supervised fine-tuning with retrieval-augmented generation, offering a fresh perspective on in-domain learning.
Stay tuned as we unravel the intricacies of this innovative approach.
Let's embark on this intellectual journey together. Our research is driven by the need to adapt large language models, or LLMs, to specialized domains. We focus on retrieval-augmented generation known as RAG, a method that allows the model to reference documents when answering questions.
However, we found that existing methods have limitations.
They either fail to fully leverage the learning opportunities provided by the fixed domain setting, or they struggle to handle the open-book nature of test settings. This led us to our problem statement. We identified the need for a method that not only enables models to learn domain-specific knowledge through fine-tuning, but also ensures robustness to instant-accurate retrievals. We likened the existing methods to taking an open book exam without adequate preparation. They either memorize the input documents or answer practice questions without referencing the documents. This approach, while leveraging in-domain learning, fails to prepare for the open book nature of the test setting. Our research aims to address these challenges and provide a more effective approach to adapting LLMs for specialized domains. Our proposed method, Retrieval-Augmented Fine-Tuning, or RAFT, is a unique adaptation strategy that marries supervised fine-tuning with retrieval-augmented generation. It's designed to train the model to understand the intricate dynamics between the question, the retrieved documents, and the appropriate answer. Now let's delve into the key features of RAFT.
In this approach, each data point is composed of a question, a set of documents, and an answer that follows a chain of thought style.
We categorize documents into two types: oracle documents, which contain the answer to the question, and distractor documents, which do not contain answer-relevant information.
This differentiation is crucial as it helps the model to discern relevant information and improve its performance.
In essence, RAFT is a robust and innovative method that not only enables models to learn domain-specific knowledge through fine-tuning, but also ensures resilience against inaccurate retrievals. As we delve into the world of large language models, or LLMs, we find their application in specialized domains is on the rise. These models are being adapted to perform tasks that require a high degree of accuracy based on specific documents.
This could range from code completion for specific software frameworks to answering questions on legal or medical documents.
The key here is not just general knowledge reasoning, but the ability to maximize accuracy based on a given set of documents. This is where our method, RAFT, comes into play, as depicted in the figure. It's a novel approach to adapt LLMs to these specialized domains, ensuring they are not just accurate but also robust and efficient. In the realm of large language models, we face a couple of significant challenges. Existing methods often fail to fully exploit the learning opportunities presented by a fixed domain. They also struggle to handle the imperfections that arise during the retrieval process and training. To address these issues, we introduce a novel strategy known as Retrieval-Augmented Fine-Tuning, or RAFT.
This approach combines the strengths of supervised fine-tuning with retrieval-augmented generation.
It not only tackles the challenges of fine-tuning, but also enhances the performance of in-domain retrieval-augmented generation.
To better understand this, let's draw an analogy to an open book exam. Traditional methods are like attempting the exam without prior study, relying solely on the book. On the other hand, our RAFT method is like studying for the exam, with a clear understanding of which documents are relevant and which are not. This approach allows us to prepare more effectively for the exam. In this case, the task of answering questions within a specific domain.
Our research introduces a novel strategy known as Retrieval-Augmented Fine-Tuning, or RAFT.
This approach combines the strengths of supervised fine-tuning and retrieval-augmented generation. The goal is to train models to understand the intricate dynamics between the question being asked, the documents retrieved in response, and the appropriate answer that should be given.
To put it in simpler terms, imagine studying for an open book exam.
You need to recognize which documents are relevant to the questions and which are not.
That's exactly what RAFT is designed to do. It's a new way of preparing models for domain-specific question-answering tasks, making them more effective and accurate. Our research introduces a novel approach known as retrieval-aware, fine-tuning, or RAFT.
In this method, each data point consists of a question, a set of documents, and a chain of thought-style answer.
We differentiate between two types of documents: oracle documents, from which the answer can be deduced, and distractor documents, which do not contain answer-relevant information.
The model is then fine-tuned using a standard supervised training technique. Now let's delve into the training process in RAFT. For a certain fraction of questions, we retain the oracle document along with distractor documents. For the remaining questions, we include only distractor documents.
This unique approach enhances the model's ability to handle inaccurate retrievals, training it to sift through irrelevant information and focus on the pertinent details.
This way, RAFT is not just about finding the right answers, but also about understanding the context and reasoning behind them.
Our research introduces a novel approach to enhance the training quality of large language models.
We focus on the generation of a reasoning process, specifically a chain of thought, which guides the model to the answer.
This involves presenting the model with a question, the relevant context, and verified answers.
We've found that adding detailed reasoning paragraphs significantly boosts the model's performance, enriching its understanding and improving overall accuracy. Now let's delve into the evaluation of our approach.
We conducted an analysis of sensitivity to the number of distractor documents during both training and testing. The results were quite revealing.
Our proposed method RAFT consistently outperforms supervised fine-tuning, regardless of whether retrieval-augmented generation is used or not. This was observed across all datasets used in our study, demonstrating the robustness and effectiveness of our approach.
Our research has yielded some key results that we're excited to share with you.
Firstly, we found that RAFT consistently outperforms supervised fine-tuning, both with and without retrieval-augmented generation, across a variety of datasets. This is a significant achievement demonstrating the effectiveness of our approach.
Secondly, we've seen that our model not only learns domain-specific knowledge, but also ensures robustness against inaccurate retrievals. This is crucial in real-world applications where the quality of retrieved documents can vary.
Thirdly, our training data is unique.
It includes a question, context, and verified answers, which prompts the model to form a reasoning chain.
This approach encourages the model to understand the dynamics between the question, the retrieved documents, and the appropriate answer. Lastly, we found that including detailed reasoning paragraphs in our training data significantly boosts the model's performance.
This shows the importance of a well-structured reasoning process in training effective models. These results underline the potential of RAFT in improving the performance of large language models in domain-specific question tasks. In conclusion, we've introduced a novel strategy called RAFT, which stands for Retrieval Augmented Fine-Tuning. This approach is designed to adapt large language models, or LLMs, to specialized domains. It's a unique blend of supervised fine-tuning and retrieval augmented generation, which allows the model to learn from a specific set of documents and generate accurate answers.
To put it simply, imagine studying for an open book exam. You need to recognize which documents are relevant to the questions and which are not.
That's exactly what RAFT does. It trains the model to differentiate between oracle documents, which contain the answer, and distractor documents, which do not. This approach has shown significant potential in enhancing the model's performance in domain-specific question-answering tasks.
It's a step forward in the field of AI, and we're excited to see where it leads us. Thank you.